make sure, I think you all did, that you have a copy, whether electronic or your actual book. And here we go. So there's not much in the textbook on regs. There's some sprinkled throughout. AC 4313 will refer to them, but we're going to be in parts 21, 23, 35, 43, and 65. Okay. And the objective is to become familiar with the Code of Federal Regulations related to propellers, and most importantly, understand your privileges and limitations as a mechanic. That's a very important part. What you can and cannot do. So you can go to part 21.3 and kind of follow along, rather than dragging you through every single thing and reading all the legal verbiage. I copied them onto here and highlighted the important parts of each one so we can try to go through more quickly than just grinding through and reading everything. So this talks about that the holder of a type certificate must report any failure, malfunction, or defect in their product, in this case propeller, that resulted in any of the occurrences listed in paragraph C that we're going to look at. So if any bad stuff happens that they talk about in paragraph C, they must report it to all the owners. And they have to report if they realize there's a defect in their prop that they just manufactured and sent out. And if they find a defect, they must report that. If it's left its quality system, if it's left the warehouse production facility. So they have to tell you. How do you think they would tell the owner? It depends what it is. AD or a service bullet. Yeah. Typically, if you're dealing with FIRs, and when you see the things in paragraph C, it'll be an AD. It's serious stuff. So here we go. This is what has to be reported. Malfunction, failure, or defect of propeller control system. What do you think what kinds of props would have a control system? Constant speed and controllable pitch. So anyone can change its pitch. And a propeller or rotorcraft hub or blade structural failure. So if they realize, ooh, they didn't manufacture this blade quite right, and its tips are flying off, they had better report that. You don't follow the rules, you could die. 21. So this is if someone wants to get a type certificate for a prop. They come up with a really cool design. They're like, this is certificatable. So, and all this talks about a propeller. 2127, that's for surplus military aircraft. But the applicant submits a type design test report. So obviously they have to do a lot of testing to be able to report on the testing. Computation, so all the engineering data necessary to show that the product to be certificated meets the applicable airworthiness, aircraft noise, and then the rest of this stuff doesn't really apply to propellers. But noise and, of course, airworthiness would apply to a prop. And then 2150, the holder of the design approval, so whoever came up with this really cool design, a really cool prop, they must give a complete set of instructions for continued airworthiness to the owner. So when you buy a prop, you must receive that. They have to give that to you. And it has to be prepared in accordance with all of this stuff. So this tells them exactly what that has to include. And if there's any changes, they have to send that to the owner as well. 2129 says each person manufacturing propellers under a type certificate must give each variable pitch propeller an acceptable functional test to determine if it operates properly throughout the normal range range of operation. So they have to take, if it goes into feather, the whole way up through, if it goes into reverse, full range of operation, and they would tell them how many times they have to test that. Because, does anyone remember from the Hartzell video yesterday, approximately how many different parts are in the prop and hub assembly of a Hartzell concept? I forget, it's like 150, 120, something like that. Yeah. So, it might have been. Anyway, a lot of parts. So you have to make sure each one of those parts, they're all working together, doing what they're supposed to, for a whole bunch of times to make sure nothing is going out of whack. And then 23 subpart echo, and this is 2324. Power plant installation. The engine and propeller must be type certificated, except, there's an exception, for engines and propellers on a level 1 low-speed airplanes. If it's a level 1 low-speed airplane, then the propeller, or the engine, can be type certificated under the airplane type certificate. So what kind of propellers do you think they would allow to be certificated under the aircraft? Fixed it. And, very simple one. What do you think is a level 1 low-speed airplane?
It's got a stall speed beneath a certain number.
Speed below a certain number, we got a code as an example. Where do you think you would go to find out what that actually means? You're very close. So if you go over to part 232005, or find the first pin, read what they find. And John found it. So, it goes with seating configuration. So, Zach was on it as an example. Seating configuration of 0 to 1 passengers.
Is there any speed thing on that?
So, on here it says low speed. But in this section...
Right, exactly. Speed is
Well, I mean, it is talking about props. So, I mean, F-16, we have 0 passengers, but you don't got no prop. So,
less than 250 knots. That's pretty slow, ain't it?
but yeah, so level 1, this one says low speed, and then may be approved. So you still had to seek approval, but it's possible it could go under airplane type certificate. Then, part 23, appendix A, instructions for continued airworthiness, and this talks specifically, well, includes propeller, any required information relating to the interface of those appliances and products with the airplane. What do you think that could be talking about when we're talking about propeller and interface of appliances? Governors. Yes. And the prop with the airplane, all that kind of stuff. So it has to tell you how to comply with that, make obviously the specific propeller owner's manual will give you much better information, more current information, more detailed information, exactly what to do with the propeller. And you have to make sure the propeller that your aircraft maintenance manual says on the airplane is actually on the airplane if you're using the aircraft manual. So the propeller owner's manual is going to give you all this information. What manual is going to take one of these subjects, like lubrication, and give you a lot more detail? Field maintenance manual is typically what it's called, or standard practice manual. All right. Now, here we go. All right. What, does anyone know which part of the FIR is very special all about propellers? See if you can find it.
35.
Very good. Zach knew it. So 35 is our special section that we're going to be in the most for this lecture. And it is airworthiness standards for propellers. A whole section just for props, because that's special. So we've got 35.3 instructions for propeller installation and operation. And they have to tell you, the FAA is telling the applicant for the type certificate, they must provide instructions for installing the propeller, and it must include description of the operational modes of the propeller control system and interface of the control systems with the airframe and engine, and limiting conditions must list the limitations. It must define what hydraulic fluids are approved, and some other stuff, but those are the most important things that they must provide you, so you shouldn't have to go scrounging. You might have to search through owner-operator manual, field maintenance manual, but both of them should have that in. And the applicant for the type certificate must prepare instructions for continued airworthiness in accordance with Appendix A to this part that are acceptable to the administrator. So they absolutely must give you how to keep that propeller airworthy. Then, going to 35.5, ratings and operating limits must be established, and it has to be in the type certificate data sheet. So that is why, what information were you looking up in the type certificate data sheet yesterday? Static RPM and critical range. So that's what they're talking about, must be in the TCDS. And it must tell you power and rotational speeds for takeoff, maximum continuous power, and any overspeed over torque limits. Okay, now we have a video of propeller failure relating to critical range and a very particular thing that was done incorrectly or ignored, whether it was by the owner or the mechanic. You can watch and listen. Whoop. Whoop. Some good lessons to be learned from this.
Have you dreamed of getting your pilot license and soaring through the sky? Introducing Private Pilot Made Easy.
So have you ever been flying along and wondered or worried about your propeller just falling off the airplane, or worse, cracking and becoming very out of balance? I know that's actually one of my biggest fears in an airplane, is losing a chunk of the propeller and having the airplane become so unbalanced that the engine tears from the airplane and the airplane's wildly out of balance. Now, that's pretty unlikely, but I certainly check the leading edge of my prop every time looking for nicks, cuts, and little dings in it. And in this case, this airplane actually did lose a chunk of the propeller. Luckily, it turned out all right. But cruising along at 4,500 feet in a pretty uneventful flight, operating somewhere between 2,350 and 2,400 RPM, just above the prohibited range on the RPM of 2,100 to 2,350, the pilot experienced severe vibration in the airplane, immediately switched fuel tanks, turned on the fuel pump, tried to troubleshoot the issue, tried to get the vibration to smooth out, but couldn't get the vibration to stop, didn't notice any abnormal indications on the engine instruments, so he squawked 7,700 and proceeded to the nearest airport and landed immediately. Now, upon landing, it became very clear to him what had happened. It wasn't in fact an engine problem. This case was actually a propeller problem. Now, the airplane you fly may not mention anything like this, but some airplanes have placards, or worse, have a prohibition on a certain RPM range, but are missing a placard to let you know not to operate within that range. It should be placarded right there on the instrument panel, letting the pilot know not to keep the engine running in a particular RPM range for too long, because certain engine-propeller combinations create harmonic vibrations that will, over time, cause fatigue cracks in the propeller. That's common, actually. That's an accepted risk in general aviation. We simply put a little note on the dashboard, a little note on the instrument panel. We don't operate within those ranges. For this airplane, it was 2,100 to 2,350. And the pilot thought he was operating between 2,350 and 2,400, above that. However, how this ended up happening is, in fact, the tachometer was indicating 50 RPM higher than the engine was actually running. So he was actually operating within that prohibited range, and not just for one flight, but this had been happening for many, many hours. This had been going on for a long time, because as we look at the propeller fracture here, as we look at this propeller blade, we can see the shiny part. That's a fatigue crack that occurred over a long period of time. The back, dull gray part is just a simple failure of the metal, as that fatigue crack let go and the metal failed instantaneously on the back 30%. But 70% of the prop had a fatigue crack in it that wouldn't necessarily be evident simply inspecting the leading edge of the propeller on your pre-flight. Now, this is so common, in fact, the FAA actually has a notice out on it that tells you, hey, make sure that you're following those placards on your instrument panels, and double check and make sure that your airplane doesn't need a placard prohibiting a certain RPM range, yet it's not installed. And it's not just the airplane, it may be the particular propeller you put on. So maybe you have a 172 that doesn't have a prohibited range, and then you swap propellers to a cruise prop, and all of a sudden you do have a prohibited range. You need to install the placard as well. Now, this incident turned out very well, and the pilot was able to get the airplane on the ground safely, but certainly this could have been a lot worse. With an out-of-balance propeller like that, shaking the airplane, it could cause a lot of other things to go wrong, possibly rip the engine off the airplane and create a super out-of-balance state, or worse, having chunks of the propeller fly off and hit part of the wing or the control surfaces of the aircraft. Luckily, this one turned out pretty uneventfully. So if you're curious at all about the airplane you're flying and the propeller that's installed on there, go ahead and look up the type certificate data sheet. We show you how to do that in our online courses at fly@mikealpha.com. Check out the type certificate data sheet, see what kind of propeller it's supposed to have on it, look in your logbooks of the aircraft, find out what propeller is actually installed, and then go ahead to the FAA website and search the AD list and find out if there's any ADs that apply to that propeller, or if there's any placards that need to be installed for it. You can find out how to do this all online at the online courses at fly@mikealpha.com and our private pilot, instrument pilot, and commercial pilot ground schools. Check out a lot of the other awesome free
So, that sounds at all familiar with a lab that you did yesterday? And what did you find in your lab that would relate to this? And did it take you to maybe a service bulletin from Piper that makes you say, oh, it must make sure it's marked in this range? And there's a little sentence, if you read through it all, that says make sure you calibrate your tachometer.
free online courses.
Okay, now it's your turn. So, you know, I love teaching, but sometimes I do it too much up here. So, here is a list of CFRs. I'm going to split you up into groups, and we'll have 6 groups. So, group 1 will do 35, 15, and that's a longer section, so I split that into taking A through C, and then D through E, F through G, part 16, 17, and 19. What you're going to do is in your group, you're going to read through it, try to figure out how to summarize it, and we're going present your section of the FARs. So if you want to elect one person to kind of summarize it, and I do want a summary in your own words, because that's a big part of this, taking all the legalese and putting it into words that actually make sense to normal human beings. So don't just read your paragraph. Give a summary. So if you have one volunteer in your group that can give a nice summary, it's perfectly acceptable. If you prefer to dramatize it, you may do that. If you want, you can use props for props. Visual aids are always great. So this is your opportunity to teach your classmates what you learn about each section. I want you to have fun with it within safe boundaries. Okay, so I'll basically do you by tables of 4, 5, 4. Okay. That'll work, yeah. That'll be easiest. So, lease table, you'll do 3515 A through C. Next one will be D through E. Back table, F through G. And then Trevor, back table, 3516. Middle, 3517. And front, 3519. So take like maybe 10, actually that'd be perfect. Take 10 minutes, and then you'll have break time. So when you come back from break, then we'll do your short, summarized presentation. So if you wanna, you can gather in here or the library or so what you can also do is do a demonstration of how you think this is carried out in a propeller, like production. Like how would they fly the thing?
So like, basically what? Some of the FARs are pretty cool. It's just like, well, of course, you want it to be safe. Like, you're not going to design it to break. Let's just take a thing. And then we can want us to be the FAA and say, no, you can't do that. So it doesn't need to be it's supposed to be like a C8.
Hey, it doesn't have to be, but I think it's more fun.
Basically,
It's like, I know not everybody.
look at it, analyze for bus system, consequences of all failures.
logic.
I mean, if you got your group assignment all sorted out, you're welcome to take a break. Make sure you're back in here at 12:30. 30. One group can have.
Or I just read off the list, but I change the words slightly.
Yeah, but you get to the glorious city of Chicago after that. You get all of the and the Columbus after that. But then but if I do like a circle, go to you guys. Yeah, I had to take a second to look at what's going on with the pants. I look down, I'm like, the pants are on the floor, then I look up,
Beat 'em up,
shorts
dog.
on.
Yeah.
Stop.
The fact that your pants are slightly skin colored.
It doesn't. I was looking at this, like, it's a little hesitation. At first glance, it's like, whoa.
All you can see is the cloth, like the.
Right, I looked at his feet first, so just shot my,
They are basically. I haven't seen the sun in about a year and a half.
they're glowing, dude.
That's pretty hot.
Break up the guild.
I quite enjoy mine as well. What kind of good?
You'll see, Christina.
I'm very excited.
I sure hope you. It's gonna be like 15 seconds long. This exercise is kirkifying FARs. Because I feel like he did pretty good at
As long as you're not.
explaining and making FARs fun.
Yes.
Doing that.
Yes,
Hands in his pockets.
he does.
That's a terrible question. chase off, even if you cancel it.
Right. And there's a lot, like, there's a website, I get so many YouTube videos, like, for maintenance stuff. On their website, and then their magazine is pretty cool. And then you also get discounts for like, what's the museum in Battlefield? There's a,
Yes.
What?
yeah, there's, so, and there's also other museums in Street, I think. So if you take advantage of it, it's totally good. I mean, just 3 months, you visit all of them.
You have to find yourself a wife.
There you go. Hey, I brought you the plate. No.
I already said that I would. The stars are aligning.
Steve just sees Steve going early. Got out.
Oh, that's no wonder you like it all. Oh, that's really good, you know?
You have Dean adopt him.
There you go.
Yeah.
We figured it out.
You could be Dean's son. You could adopt you and you can become a citizen.
Yeah.
Have you read it fast enough?
You can adopt you.
If I was 18.
It'd be Dean and Dan Peterson.
Something.
Dean and Dan.
Or I could get one of my brothers.
Can you adopt someone if they're older?
Yeah.
You can?
Martin's done it.
Dang it, because I just thought of it. What about the one that
Adopting you.
What about the other one?
Sorry, I was thinking of
He's
my
getting married. You can just. Wait, you don't beat him up?
See what Steven says.
No.
I like that plan.
A little wordy, but.
Just for the legal benefits.
Yeah.
Yeah.
Tax purposes.
Do it. Do it.
Yeah, we gotta find someone that's
Say if you would.
Yeah.
Brother.
It's cheaper to become a member and still pay.
Obviously, he doesn't use it.
It's $80 plus. According to Christina, $40.
Stress.
I think that's what it is.
It's $40. Way cheaper.
Yeah, that's just how the.
Beat him up.
Any bigger? Oh.
My
I
little
was telling
sister's
this
bigger than
today,
me too.
he can squat like 600 pounds. He doesn't even work out. He just has that, you know, God just gave that to him for whatever reason.
Scottish hands.
What's his brother?
I was talking about you.
Is he bigger than you?
Yeah, his, I think like, it's my waist size, is 32.
Yeah.
I think if you did the same thing to one of his legs, it'd be like 34. Like he's a big boy. He's like an inch shorter. But he's fast as me too.
You really just, you just really.
Understand.
Nah.
Yeah, he's got a bad personality.
Yeah, that'll do it.
Well, at least you got that on.
He's gonna be a preacher. But no, there's really.
He's getting worse. I mean, he's pretty.
He's pretty lazy. He's not a very hard worker.
Have you ever seen Machine Gun Preacher?
Machine gun preacher?
Is it similar to Velocipaster?
Based on a true story.
You say Velocipaster?
Yeah.
You know Gerard Butler?
Yeah.
Yeah, it's that guy.
It's based on a true story.
Based on a true story. This guy that went to Africa like as a missionary, and he started like, you know how they have all these militants in Africa who are like super nuclear. He started and all of them.
Yeah.
A through C is all about determining the hazards associated with propeller and to assess and analyze all the associated risks. So, you know, major risk would be propeller failure in flight, which if one of the prop blades failed, be a little unbalanced, and could rip the engine from the airframe, as you see here. So we've got a cracked mount on there, could likely have propeller failure. So that would be a secondary consequence of propeller failure. And the probability of propeller to fail in flight during testing is less than like 10 times -7 to like that's like very small. Like I don't even math that small. It's per hour that the prop is likely to fail. So like very small chance whatsoever. And then there's certain critical components of the propeller, which is referenced in Part C, that they cannot be tested with numerical values. So there's no adequate representation of how likely they are to fail. And the administrator to the FAA will deem required stuff necessary to certify them. Like major components can be like the hub, critical area.
Good. Thank you very much. All right, group 2, continue on. Still the group echo.
You go, Parker.
Okay, so this is the summary we came up with for D and E. So this is what we said. If you're using a safety system to prevent propeller failure, there needs to be an analysis of the possible result of a safety system failure as well. Items included in this analysis would be dependent on the inclusion or exclusion of maintenance checks, making sure safety devices are working properly, fatigue assessments, and inspection of any other instrumentation used in the safety system. So what we think it's trying to say is that if you were to have a system that is monitoring how or the condition of your prop, you would then have to have a system also for monitoring that system. So if you're using maintenance checks, any instruments that are used to monitor that, then you have to monitor those as well. So basically.
Group 3. What?
No, Joey said he's got it.
Zach said he literally got it.
I never once said that.
Oh. Are you having a hazardous group effect?
I told him he's doing it. Everyone else pointed at him.
You literally said you had it.
He ain't got no proof of camera lights on. Austin won't look for him.
Zach, you literally said you had it. You know.
Everybody knows. Just all of you do a little bit.
Easy now, easy now.
Everybody share.
Reads the first time.
So basically, it's applicable like to the safety analysis, but it's talking about everything except the propeller. So like the prop governor, reversing. It says like synchro phasers and synchronizers, and then like thrust reversal systems. So basically, it's saying that like it goes over the parts of you got to understand the parts, not just of the propeller, but stuff that like can affect the propeller. And some of them are the development of excess drag, a significant thrust in the opposite direction to that command No, it's just basically referencing that thrust reversing and changing a constant speed and stuff like that. Testing that.
And that's all in subpart G, giving definitions for failures. So failure specific to constant speed, failure specific to variable pitch props, failure specific to fixed blade prop.
Anything else?
The end.
All right.
So basically it's just saying that there needs to be a procedure for engineering, a procedure for manufacturing, and a defined management system for making sure that the propeller is airworthy.
Acro dancers. Yeah, 3517 is pretty straightforward. It's just regulations for materials and manufacturing methods. And you have to have established data for manufacturing and the materials. It has to be suitable for the environmental conditions that it's going to experience, so it's not going to fall apart. And so it has to be able to survive the adverse conditions that it's going to be in, spinning really fast so it's not going to fall apart on you. And the way that it's constructed has to be acceptable to the administrator. So it's just, they have to like it, I guess. That's pretty much it.
Very good. And the last group.
Here, I'll stand over here. All right. So we got our prop manufacturer representative here. I think I'm technically the FAA.
Yeah, he's
So, and then we got our
our
product.
propeller.
Our prop.
This is
Oh!
So I kind of hate to tell you, Gavin, but you have to design that and all the parts associated so that the chance of that is minimized before each overhaul.
Really? I thought it was supposed to do that. That's it.
Oh, okay, that was pretty good. So hopefully, and that's what you kind of have to do as you look at regulations, because you will have to be staying familiar throughout your career, but being able to put it into your own words that make sense in your own mind, practically, like these guys did, rather than all the legal mumbo jumbo fancy words. Any questions on that stuff? All right. So then we move to 3521, and a lot of this is dealing with variable and reverse pitch constant speed propellers, because a fixed pitch prop, not a whole lot other than just blade failure if it's the wrong fit. When you get to a complex hub, there's tons of stuff that can go wrong. So it says that no single failure or malfunction in the propeller system will result in unintended travel of the propeller blades to a position below the in-flight low pitch position. So all the contraptions that you have in the hub, if one of them fails, it cannot, you have to have backups so you still have control over your blade angle. And then failure must be shown to be extremely remote, like what Ryan was talking about, very teeny number. And then propellers incorporating a method to select blade pitch below the in-flight low pitch condition, what blade angle do you think that would actually be? Reverse. Yep. So all that fancy words to saying if it can go into reverse, you must make sure that it has an indication to tell the flight crew that it is in reverse. So if it can be in reverse, it must tell you when it's in reverse. And then failure of that reversible system must not negatively affect the control of the propeller. And this, I will have a very scary story coming up. So you can be excited about the very scary story. That will be in a little bit. Then you have 3523 talking about propeller control systems, and there's some good stuff in here. So if I could have someone volunteer to just read through these 3 paragraphs. Thanks.
Propeller control system operating in normal and alternative operating modes and in the transition between operating modes performs the functions defined by the applicant throughout the declared operating conditions in a flight envelope. The propeller control system's functionality is not adversely affected by the declared environmental conditions, including temperature, electromagnetic interference, high intensity radiated fields, and lighting. Environmental limits to which the system has been satisfactorily validated must be documented in the appropriate propeller manuals. A method is provided to indicate that an operating mode change has occurred if flight crew action is required. If in such an event, operating instructions must be provided in the appropriate manuals.
Thank you. So basically, to summarize that, paragraph 1, it must do what you say it does, or what the manufacturer. So if they say, this is what it's supposed to do, it better meet all these criteria. And then it must hold up to the environmental conditions that you say it is capable of operating in. And again, kind of like the other ones, it must have proper indications in the flight deck of what it's doing, and it must say in the pilot's operating manual what those are, how to read those. Then 3523, same thing. If somebody could read 1 through 4. Any volunteer? Go ahead.
No single failure or malfunction of electrical or electronic components in the control system resulting in a hazardous propeller effect. Failures of malfunctions directly affecting the propeller control system in a typical airplane, such as structural failures of attachment to the control wire or overheat, do not lead to a hazardous propeller effect. The loss of normal propeller pitch controls does not cause a hazardous propeller effect under the intended operating conditions. A failure or corruption of data or signals shared across propellers does not cause a hazardous propeller effect.
Thank you. So to summarize, number 1, it needs to be able to have an electrical failure, not have a hazardous effect. And number 2, if you're on fire or your aircraft is on fire, or something causes a control cable to break or something, you have to have redundant systems so that doesn't cause failure. This is just talking about another default mode. And this one, failure corruption of signals across propellers, that's talking about twin engines, and we're going to talk about this later, a synchronization system where you synchronize electronically the props together. If that, fails, if that pitch control does not cause a hazardous propeller effect under intended operating conditions. So, normal propeller pitch control, we're going to talk more about that in constant speed propellers, but you can control through RPM your pitch through a pretty significant range. So you can say, oh, I'm high at cruise, I want a nice high pitch to take a big bite of air, have high airspeed, or I'm going to draw that back, have a low pitch. If you lose that control, like let's say the cable to your cockpit control breaks, bad day. If you lose that normal propeller control, the default that it goes to should not be a hazardous effect. So it should, if you, and we'll talk again about this in constant speed, but pretty much every prop, if you lose the control cable, it's going to default to a reasonable low pitch. So then you have, you're capable of high RPM, maybe you had to fly a little slower, but you still have control, can land, all that. And also, if you lose oil pressure, it's going to assume you lost engine power. So then if it's a twin, that's when it would fail into feather. But that's kind of like two different failure modes. So if you lose normal prop pitch control, it should go into low blade angle so you can still have a high RPM if you need it. And not fail into a high blade angle where now you're overworking your engine, you can destroy your engine, destroy your prop. Bad things can happen. Does that answer your question? Yeah. Any other questions? You don't ask the right questions. 3523. And this is talk about electronic propeller control systems. Needs to minimize the existence of software errors and has to make sure that failure or corruption of airplane supply data does not result in hazardous propeller effects. So very similar to the end of the last one we were looking at. And we've come to another participation. So this, 3533 through 3543, there's a whole lot of really good information. But rather than me droning on through it, I'm going to split you up into 11 groups. And same thing as before. Read through the section you're assigned and summarize it either in your own words, do a dramatic portrayal of it, whatever whatever you so desire. So let's see, I need 5 groups of 3. So we'll go, let's see, 1, 2, 3. You're in one group, and your group 1, you'll do 35, 33. And go 1, 2, 3. With Leo, you'll do 35, 34. And then 1, 2, 3, you'll do 35, 35. And 1, 2, 3, Isaac,
required after 20 runs for 30-second duration.
Yeah, yeah.
Or just have data that proves that your propeller is good.
Very quick. Yes. So. You can take, how would you summarize the whole thing, like without giving us this specifics? Yeah. And like you could pick one, you know, like the one you think might be the most strength. Like give us summary and things like that. And this is one example out of all of them.
Are you really?
That's very all right. I think everybody's got it back in. Our first couple of groups are ready. Is there any group that is begging for more time to actually do the summary? Okay. So, group number one, if you could come up and 35-33.
Alrighty, so in 35-33, it says that each applicant, so the propeller manufacturer, must furnish test articles, testing facilities, and competent personnel. So you've got to have documents to record and proper tests to conduct on the propeller. And you've got to have the appropriate facilities and equipment to test those in compliance with the FAA. You need competent personnel to get the job done. You've got to test all automatic controls and safety systems that are needed. So if you're testing the prop governor in the hub, you wouldn't necessarily have to run the DI spoos because it's not applicable to the test. Then, yeah, that's in part C where it's, that was part B. And then part C, if your facility isn't able to test the equipment or components properly, you've got to have another facility that's able to test those components. Or if you're installing somebody else's governor with your prop, that would already be tested. So the facility would not be required to do that. Want to add anything?
No, you pretty much nailed it.
Sure. 35-34.
All right, so this is about testing. When articles are tested, they have to be inspected before and after the test and documented. During the test, only minor servicing or repairs are allowed, and they must be documented. If it's anything major, you gotta talk to the FAA again. That was it.
35-35.
So in 35-35, so for
to make sure the propeller and components is like have a good condition or strength when it operating. So we need to make do the centrifugal load test, that which is we test the propeller or the components with twice on the load than the normal operating condition. And it's just such as like the hub, bed rotation system, counterweight, or like spinners, de-icing equipment, and the other stuff. And this centrifugal load test, it doesn't apply to the fixed pitch wood or metal propellers with conventional design.
Okay, we ready to start the test?
Yep.
Well, it looks like our test has failed. We have thrown our 4-pound bird at our prop, and it has hit a significant area and failed. So that does not pass our test.
So 37A basically says it does not apply to wood propellers, but it says that fatigue limits must be established by the manufacturer for high fatigue components, so like hubs, blades, and how they're held to the hub.
You got to. So the fatigue limit, so this is like what it's talking about when what it has to take into account whenever they're doing the test. So basically, if something fails, like if it was to fail, they have to take that into consideration and how like that's going to affect flight and be considerate of that, like vibration patterns, and they even go to like helicopters and say cyclic load patterns that are expected while the aircraft is like in service. Then it's also just talking about deterioration of the prop while it's in service and how that is also going to affect it during the longevity of the life of the propeller or rotor blades.
Then after that, then they do a fatigue evaluation of the prop and make sure that none of the things they found are hazardous for in-flight or to anybody else.
Manufacturers need to demonstrate that non-wooden propellers can survive a lightning strike.
When an endurance test is performed on a propeller, it must be done on an engine, and it has to do it without evidence of failure or malfunction. A variable pitch propeller must be subjected to one of the following tests: a 110-hour endurance test that must include the following conditions: 5 hours at takeoff power and rotational speed and 30 10-minute cycles composed of acceleration from idle, 5 minutes at takeoff power and rotational speed, deceleration, and 5 minutes at idle, 50 hours at maximum continuous power and rotational speed, and 50 hours consisting of 10 5-hour cycles composed of 5 accelerations and decelerations between idle and takeoff power and rotational speed, 4 1/2 hours at approximately even incremental conditions from idle up to, but not including, maximum continuous power and rotational speed, and 30 minutes at idle.
Anybody want to flight test propellers?
So 3540 is functional test propellers, so range anywhere from 1500 to 50 cycles, pretty much like this. 1500 to 50 times, depending on what kind you got.
So 3541, your blades need to be able to survive over speeding and over torquing. So you either have to have data that supports that your propeller can survive that, or a performance of 20 runs each of 30 seconds duration for both your overspeed and your over torque. Yeah, that's about it.
So what 3542 is saying is basically that the applicant has to recreate the operating conditions which the pitch control system is going to encounter, and every single part of the pitch control system has to be able to withstand those tests. And it's for the declared time between overhauls or a minimum of 1,000 hours of operation service.
It's like under normal load.
Yeah.
Did you say that?
Yeah, well, not really. But so yeah.
Right. And 5543.
So we got hydraulics components. You have to test your hydraulic components to 1.5 times proof pressure without any leaks, and then 2 times the max pressure, but you're allowed to have small leaks through like through the seals and stuff.
That was very good. Any questions on any of that, Frank?
The overspeed, the 20 runs for 30 seconds at maximum propeller overspeed condition. Is that maximum speed determined by the engine that it's being put on? Or
It says maximum propeller overspeed. So depending on its length, weight, all that, it would have. Very good question. Because the engine would have different limits, probably, because you could put a different prop on the engine. Yeah. And they affect each other. But the propeller of what force it's going to take. Without hitting the speed of sound. Some do at the tips. Any other questions, Sean? All right, I think we have time. We'll break for the very scary story.
yay.
So, this aircraft on April 5, 1991. I won't ask how many you were born. Atlantic Southeast Airlines Embraer 120 left Atlanta, Georgia, so Ryan's home state, at 13:47 local time for Brunswick, Georgia, as Delta Connection Flight 2311. At 14:48, so about an hour later, the aircraft was cleared for a visual approach to Glencoe Jetport in Brunswick, Georgia. The crew acknowledged the clearance and then made a routine call on the company frequency. There was no indication of any problem. Witnesses, it's always bad when you're reading through a report and says, witnesses, reported that all appeared normal as the aircraft entered a 180-degree turn from the downwind leg with about a 20-degree bank angle and a gradual descent rate. As the aircraft completed the turn, it was seen to pitch up about 5 degrees and then roll left. It continued to roll to approximately 90-degree bank angle and pitch nose down. Witnesses reported a loud squeal or whine just prior being a fairly low pitch coming in on final, but what if it's a very, 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 very low pitch? So, and that's what we'll find out later in the accident report. I went into reverse. And leading to enter low pitch mode, leading to loss of control. The propeller control system failure was due to the disengagement of a 36-inch long oil transfer tube spline and a quill spline. So we have, now this is constant speed, so it's way more in-depth than a controllable pitch, but still, you have things controlling oil to the prop that'll change blade angle. So we have this oil transfer tube and then this quill spine. What happened was, so it disengaged. Once disengaged, the propeller then was free to change independent of the propeller control unit. So no matter what the pilot did with the prop control, it completely lost control, lost connection. The disengagement occurred after the harder, rougher surface of the titanium nitrided transfer tube acted like a file, causing abnormal wear on the softer quill spine. So it had worn it down over time there. The failure occurred within 800 hours of service. The first ever in-service anomalies with quills had been discovered only weeks before. 2 were returned for examination after operators were unable to perform the routine feather-unfeather ground check. After this discovery, Hamilton issued an alert service bulletin that included a description of ranges of acceptable transfer tube surface characteristics. These could be readily identified by surface color. So in the bulletin, it was a diagram somewhat like that. The spline surface of the titanium nitrided transfer tube used on the accident aircraft had a bright gold or shiny finish, and such tubes were not acceptable for continued use, but they had to go and read this alert bulletin. The titanium nitrided transfer tube had been introduced as a minor modification, replacing the original nitrided transfer tube after a series of testing. The NTSB note that the design change paperwork was reviewed by FAA certification engineers and approved. However, the first titanium nitrided transfer tubes did not enter service until about 2 years after they had approved it. The NTSB found that wear of the quill was not considered during the certification of the propeller because they thought it was a very light torque load on the quill during flight. They were wrong. They, however, did not fully consider the effect of vibration creating relative movement, something the testing had not replicated. The NTSB determines that the probable cause of this accident was the loss of control in flight as a result of a malfunction of the left engine propeller control unit, which allowed the propeller blade angles to go below flight idle. So they went the whole way into reverse. Contributing to the accident was a deficient design of the propeller control unit by Hamilton standard and approval of the design by the FAA. So they both got nailed. Hamilton standard for bad design, FAA for they approved it. They didn't do all the checks they were supposed to. And the design did not correctly evaluate the failure mode that occurred during flight, which resulted in uncommanded and uncorrectable movement of the blade emergency one right away. Then they superseded it with one link to a service bulletin of how to inspect. They increased inspection, and then they came out with a replacement. Now they say, oh, you need to do the same inspection on other models. Then finally things started to settle down, so they increased inspection times, as long as you comply with these previous ones. Then they came out with another better way with a secondary drive quill, more redundant systems, and then some more inspections. Those are just a couple of the AVs that were linked to that incident. Any questions on that? Yeah.
Did you say 3521 came about because of it? Or
So,
they were negligent of it?
they were negligent, I believe. I didn't check the date on those, which way it was. But yeah, either they were non-compliant or.
So how is the FAA held accountable? Is that like reimbursement to families?
Probably, yeah. And probably who the individual that actually did that by manning control towers in Alaska. Okay. Can take a break and come back at 35.
And I was going to ask, I forget which FDR we were reading, but something about, might have been 3523, something about like, basically if the pitch control fails, it has to default to tethered, right?
So,
Or
it
that's,
depends what fails.
okay.
If it's failing and you have engine power, it should fail to a low pitch, like a takeoff pitch.
Okay.
Because that's, like, you have, like, you probably slow down airspeed, or you will slow down airspeed, but you can still get places where you can information of the propeller's features and data, what systems and installations are available, how the components and systems are controlled, how they operate, how to uncrate it, how to check it, how to lift it, how to install it. That's actually very important because if you're a really strong dude, you can't just grab the prop and whip it out of its box. There are specific lifting points. They don't really care about you, they care about the prop, where you lift the prop. They don't care if you hurt your back, but don't be breaking the prop. I care about your back. Then instructions for propeller operational checks, how to properly check that it is operating correctly. Recommended periods at which it should be cleaned, adjusted, tested, applicable wear tolerances. This is sounding familiar because it's basically saying what some of the other parts said. It must have troubleshooting information, how to remove and replace propeller parts, and it also has to list any tools that are needed to do any of those things. That's all what must be included in the manual. Now, the manufacturer can split this up. They can say this goes in the owner-operator manual, this goes in the field maintenance manual. So sometimes you have to kind of decipher where that information is, but it will be available. And then for propeller overhaul, the order and method of disassembly, again, cleaning and inspection, fits and clearances, which you're probably going to soon be having fun with that, and recips, repair methods, order and method of assembly, how to test it after assembly, how to store it, and once again, any special tools needed for overhaul. Do you think, we didn't talk about this yet, do you think you can overhaul a propeller? No. Correct. You cannot. But if you get hired by a repair station and you get the training, then maybe you will someday. This is 43.3. Persons authorized to perform maintenance, preventative maintenance, rebuilding and alterations, and it talks about propellers. So, order of mechanic certificate may perform maintenance, preventative maintenance alterations as provided in, part 65. We're going to see what part 65 says about if you do maintenance you're not supposed to do. Then, 43.7, and this is again, persons authorized, all this stuff for propellers, and you may return a propeller to service. Once again, propellers are special, it's propellers, airframe, engine, and appliances. It's that group of four. 43.9, this should be very familiar to you. For your maintenance record entries, but propeller is listed right there, and your signature constitutes the approval for return to service for your specific work performed. Just a helpful tidbit on 43.9, I don't know if anyone told you, there is, I'm sure Kirk did, an advisory circular, 43-9 Charlie, that fully explains maintenance entries. So if there's ever any question, or if you're later on, maybe you work for a shop that they pre-print entries, you just slap a label on, and then later you're out on your own, like, ooh, how do I do what it says? Go to the 43-9 Charlie, and that will give you more detailed information. And CFR 91.417 states that, I'm going to actually ask this. Some of you, I've talked to you already about this. How many of you think that the propeller must have its own logbook? Like you have an airframe logbook, you have an engine logbook. How many agree or would say the propeller needs its own logbook? How many say it needs to be documented, but it doesn't really matter where? And that's actually correct. So, you must document everything that you do to your propeller, must be a logbook entry, but you must have logbook entries, but they are allowed to be an airframe or engine. Any questions on that? And that is 91-417 states that. Yes.
So can you sell a propeller, like just, when you take it off the plane, you sell just the propeller?
If you have the,
Like, would that be weird if you don't have a separate one?
it would, yeah, very much
It
the
does.
case. Yeah. You have to like go copy those out. Yeah. So pretty much everywhere should have a separate propeller logbook, but. Then 4311, and this is maintenance record entries for propeller, and once again, should be familiar with this, and it does say shall. Why? Logbook entries for inspections, and you're going to have opportunity to do maintenance entries for just maintenance, and we're gonna have you doing 100-hour on a prop, so then that will be an inspection entry. So make sure paying attention to that kind of stuff as you do that. And 4313, general performance rules. It talks about propeller must have, if you're working on it, current manufacturer's maintenance manuals, and you shall use tools, equipment, test apparatus necessary to assure completion of the work in accordance with accepted industry practices. If special equipment or test apparatus is recommended, you must use that equipment as acceptable to the administrator. And this is, there's some things you might be technically allowed to do, like balancing a prop, but if you don't have the equipment, which is actually very expensive to do it, then you're stuck. So that's kind of how some of these manufacturers limit the people that can do balancing and different things. Is they say, and it lines up with this, you must have this equipment to do this check, and then they make it really, really expensive so that only they can do it. Tricky. And then any repairs must be at least original, equal to original, or properly altered condition, and resistant to vibration deterioration. Do you have a question?
Yeah, so we're allowed, as AMPs, we're allowed to do 100 hours on airframe as well as power plant. Does that go for props as well?
It does. Yep. It does. Good question. Oh, yep. If you don't comply, you die. Ooh. Whoa, I like that. If you don't comply, you die. Oh, sorry. Now we get into Appendix A, Part 43, Major Alterations. And under Power Plant Major Alterations, it talks about propeller reduction gear. If you do anything with that, that's considered a major alteration. And then props has its own list of major alterations. So changes in blade design or hub design, changes in governor or control design, installation of a prop governor or feathering system, installation of a de-icing system, and installation of parts not approved. So it says up here, these are major alterations when not authorized by prop specifications. So if the TCDS says I can have governor A and governor B on this propeller, and my prop has governor A, if I put on governor B, is that going to be a major alteration? No. If it's in the TCDS, that is authorized. If it is not in the TCDS, then that is a major alteration to put on the governor that's not listed. And you probably hopefully saw yesterday, sometimes you have an engine and two different props listed for that. Or a prop and two different governors, or a couple of de-icing systems listed. So all those would be approved, but if it's not listed, So this is an old, simple type of reduction gearing you could repair, but very, very rare. Now, propeller major repairs. This is very important. Any repairs to or straightening of steel blades. They will ask you, can you do such and such to a steel blade? You can't do anything ever to a steel blade. Repairing or machining steel hubs. So basically, steel, no touchy. Shortening the blades. Bless you. Cannot shorten blades. You cannot retip wood propellers. Replacement of outer laminations on fixed pitch wood props. Repair elongated bolt holes. Inlay work of wood. Any repairs to composition or composite blades. So if it's composite or steel, we cannot do any repairs. Replacement of tip fabric. Replacement of plastic covering. So a lot of these apply to wood props. So if it's steel, no touch. If it's composite, no touch. If it's wood, be careful, check through. But we haven't seen much with aluminum other than you can't shorten blades. Repair of propeller governors. We're going to talk about propeller governors. You're going to take one all apart to be able to understand how it works inside. But enjoy that because you won't be disassembling them in the field. Overhaul of controllable pitch props. So that's where that's like, nope, can't overhaul. And for aluminum blades now, repairs to deep dents, cuts, scars, nicks, etc. So how would you know what deep is? Where would you go to find that? Field manual maybe. Probably owner-operator, propeller owner-operator maintenance manual. And that would tell you what the limit is. But if it's not a deep dent, cut, scar, or nick, you can repair it on aluminum. And then repair or replacement of internal elements of plates. Any questions on any of that? So what could, do you remember what is preventive maintenance? Who can perform preventive maintenance? So what do you think could be preventive maintenance on propellers? I'll show you. So technically, this is the only thing on the list. Replace any cowling not requiring removal of the propeller or disconnecting the flight controls. So technically, to do anything to a prop, you have to have AMP. Do people follow that? We had some people in the past, some aircraft owners, that they're like, oh yeah, I found out next to my prop, and like, don't ever tell me that again. So you get your AMP, because that is not legal. And if you don't follow the rules, if you don't comply, you die. I'll wear that out. All right. Appendix B of Part 43, recording major repairs, major alterations, and just talking about the 337 in duplicate, going to the owner in Oklahoma City for the propeller. Would you, as an AMP, ever fill out a 337 for a propeller? No, because you cannot be doing those repairs. Unless you get hired by a repair station, go through the training, and then you could. And then it says some 100-hour things. Shall inspect propeller assembly, looking for cracks, nicks, spines, oil leakage, bolts, proper torque, safetying, anti-icing devices, operation defects, control mechanisms, make sure proper operation, mounting, and correct travel. Here it tells you that you will be tested specifically on propellers and very common, is to file out a nick in an aluminum prop. So make sure you're comfortable with that. Or you might die. That one really bad. Then 6581, and this is finally the infamous limitation. It says, certificated mechanic may perform or supervise maintenance, preventive maintenance, alteration of aircraft plants or part thereof, but excluding major repairs to and major alterations of propellers. And then also that's where the instruments comes in. So 6581 is the part that says we cannot be doing major stuff to propellers. Then 6587, mechanic with a power plant rating, so you do need power plant rating to be able to work on props, may approve and return to service a propeller or related part after you performed, supervised, or inspected its maintenance and alteration, again excluding major repairs, major alterations, and you may perform a 100-hour inspection as required by Part 91 on a propeller. So there's that allowance. All right. Whew. Any questions on all of that? Here's a question. I'm going to read each statement and then I want everyone to vote true or false. So number 1 says, a mechanic certificate with a power plant rating authorizes the holder to repair deep scars, nicks, dents on an aluminum propeller blade. How many say it is true? How many say it's false? Excellent. And number 2 says, a mechanic certificate with a power plant rating authorizes the holder to perform minor straightening of steel propeller blades. How many say it's true? How many say it's false? Excellent. So you should now be familiar with CFRs that apply to propellers, and most importantly, your privileges and limitations. Follow the regulations. That's the end of that portion of lecture. I think I was contemplating doing a little bit of tomorrow's lecture, but the lab for today is pretty involved. So I'm just going to give you time in the lab, and I'm going to quickly swap over, open it up, and then go over some things. Okay. So I have just opened up lab 3, which is on propeller alterations, and this, so Paul spent a lot of time developing this lab to make it real world scenario. It gives you, I just read through this. You're a new A&P working in a small general aviation shop. Your boss just assigned you the job of installing brand new propeller blades on the left and right engines of a Beech 95. Get all your things together, start to work, and you realize new blades are slightly longer than the old blades. So it walks you through the whole scenario, the conversations you have with your boss, which this could happen depending where you go. But you must do these questions in order, because it walks you through scenarios that says this happens and then this happens, and then so if you do them out of order, you're going to get completely confused, get completely wrong answers. So do it in order, and there is going to come a point where you have to look up a piece of information, an application guide from Hartzell. So I'm just going to show you a little bit of Hartzell's website so you can get those resources. So if you go, and you can just look up Hartzell propeller, and it'll tell you that, go to the Hartzell site. And then under services, this drops down, and you can come to reference library. So click on reference library, and then in here you have manuals. So then once you go to manuals, here it has owner's manuals, non-aviation, field maintenance manuals if you need ice protection stuff. Here is the application guide. It's going to ask you about, you go there, and then you make sure you have the right number, which there's only one, so you will. So you'll be going there for some information. And make sure as you go through the questions, you're reading all of this information very thoroughly, because there will be, specific, we'll give you all the information you need to answer the question. Make sure you're reading all the details. When you go, you'll be in airframe TCDS, propeller TCDS, and engine TCDS. So that being said, you may work in groups of 2 or 3, so you can have several screens. You can use the workstations out there, library computers. Then you can have a couple of TCDS's documents up and be comparing them without having to be going back and forth between the computer. So totally fine. In fact, recommend working in groups of 2 to 3 so you can be having those documents up. And also, again, if there's any notes in a TCDS, as I said, refer to notes.